In this tutorial, we will be talking about named entity recognition. Why do we need that? Named entity recognition is for isolating a type of the entity rather than assigning the value to a slot or parameter. Two different slots could have the same type. For example, user says, "Take me to Seattle and stop in Bellingham." As you can guess, Seattle and Bellingham are the places, but Seattle is the target where we want to go, and Bellingham is a stopover. In order to achieve that, we need to create a separate layer that would isolate the type. This is the way we mark each entity with its type. The syntax is very similar to labeling value with the slot name. Ampersand in front tells the system that this is a named entity instead of a slot name. So Seattle and Bellingham are marked as p_place, which will replace in original utterance word Seattle with place and Bellingham with place. So the utterance will be transformed from "take me to Seattle and stop in Bellingham" into "take me to p_place and stop in p_place." So p_placed is a recognized named entity. So let's create separate layer and add this content into a separate file. We call it inar.txt. Let's also modify our configuration file for the project. From now on, we have not one layer but two. You can omit the name of each layer or you can add it manually. Like so. Let's assume that p_place corresponds to US city. You can Google a little and find a major city in US and just cut and paste in here or in separate file. The beauty of slist section that we discussed earlier is that you can just prefix the list of the cities in front of it, and that's all there is to it. By doing this, you expose GUS city variable as a list in a scripted fulfillment environment. To keep this example clean, let's move the list into a separate file and call it US city.txt. Also, don't forget to add it into configuration file. Why do we have to do this? Let's create script section and define p_place handler. This handler is designed to verify the value retrieved by the NLU model and return whether it's a valid value or not. If the value returned is false, inference will be ignored and Seattle will not be replaced with p_place. Implementation is very simple. That's it. All we have to do is to check whether this value is actually in the list we defined in the CList section. Let's convert everything to the lowercase and also the list of US cities. Now let's go to the main training file in lesson 1 project over here and replace Seattle with type value p_place. Also, we don't need this definition anymore. So as you can see, we have p_place, which is a type assigned with a slot. We also do it for Vancouver here too. Okay, let's train it now. While it's training, please note that now you see two layers, named entity recognition layer and intent layer that we created separately. Okay, training is finished. Make sure you click on the project or all, and now we can try it. Take me to Seattle.
Okay, I will take you to Seattle.
Let's take a look at the inference. Intent is navigate, prompt, okay, I will take you to Seattle, and the target is Seattle. Let's take a look at the log file. In the breakdown here, you see each layer separately. The input for the first layer was take me to Seattle. You see that p_place type was recognized correctly and the value of for p type is Seattle. In the second layer, input utterance is take me to p_place, intent is navigate. p_place also resolved to actual value Seattle, which is assigned to slot T target. Let's try another example. Take me to New York. And as you can see, we didn't receive valid inference. What we did wrong? Let's take a look. Looking at the utterances in this file, we see that we only added one, which is not enough. Let's modify this sample to make more utterances. What we did here, we defined Seattle as Seattle, Vancouver, or one unknown word, or two unknown words, or three unknown words. So now we would have few more samples. Let's build it and try it again. Take me to Los Angeles.
Okay, I will take you to Los Angeles.
As you can see, now we got unknown city recognized correctly. You can pause and review the log file here. Let's try another one. take me to blah blah blah. Let's take a look at the inference. It's not recognized correctly because we used tPlace handler, which verifies whether this value is correct or not. This way you can validate values of the entity and act as desired during fulfillment stage. To sum up, project can contain one or more named entity recognition layers in order to isolate types. Those types names are used to replace the actual values, so the original utterance gets updated and passed to the next layer as an input. In the next layer, the entity is labeled by the slot name, and as a result, slot will be assigned with the desired value from the original utterance. Please take a look at this diagram. It shows a project with 3 layers, where the first one is named entity recognition, second is the slot label assignment, and the third one is to infer the intent. This is recommended project structure where each layer is responsible for its own dedicated task. In addition to that, it is most optimal from the training time perspective as well. There is an alternative way to define named entity, that is using regular expression section. Previously, we have discussed how to use regular expression to make substitutions in the original utterance. This is only one function of the regular expression section. Another one is to facilitate named entity recognition. If you remember, replacement is made when ampersand sign is present in front of the replacement string. Like this. To define named entity using regular expression, ampersand sign should be omitted, and here is the format how to use it. It's pretty straightforward. There are 2 advantages of this method. First, it does not require training, and the second, there is no need to create a separate layer. In some cases, contextual information used to isolate named entity is complex, and in this case you should consider using method discussed earlier, that is, creating trainable separate layer.